Hello, and welcome to a new episode of the Ajay Bruno Show. We have a phenomenal guest today. Dr. Seth Shostak is a senior astronomer at the SETI Institute and has appeared in many documentaries. You may have seen him in. Hello, and it's an honor to have you on.
Yeah, thanks very much, AJ.
Sure. Well, let's talk about your background first. What was it that first drew you into astrophysics, and were there any particular heroes of yours in the field who most inspired you?
Well, heroes. Well, I was interested in astronomy as a kid. I mean, I think a lot of kids are, actually. I don't think there's anything particularly surprising about that. I used to go to the planetarium in New York when I would go visit my relatives up there. And, there were a lot of science fiction films that I would see essentially every week. So, I was drawn to the idea of aliens by that. By age 10, I guess I built a telescope and that sort of thing. But then when I went to college, I studied physics as an undergrad. And then in grad school, I actually entered in physics, but I switched my major to astronomy. Well, it was only a few years after that I realized that the techniques of radio astronomy, studying galaxies, which is what I was doing, are not so different from SETI. And so when I got a call that the SETI Institute was interested in hiring me, I said, sure. And that's kind of how it happened.
Now, before you were at SETI, you also worked in the Netherlands for many years. So what was that work like, and how did that differentiate from your work now?
Well, I was at a university, so to begin with, there was an occasional teaching load, very little actually, but mostly I was doing research using an interferometer, which is an array of antennas that had been built in the Netherlands in the 1970s. I don't think many people know this, but the Netherlands generally ranks as number 2 in the world as a country in terms of astronomy research. They have a long history of doing that, and it's because they're a seafaring country, or were, even more so than they are today. And so astronomy was useful for navigation, so that was part of the deal. But in any case, they had a big astronomy department. They had this big radio telescope, and I was using it, as I say, to study galaxies. And I actually, together with another guy, we did the first SETI experiment. Actually, another guy was another woman. We did the first SETI experiment in the Netherlands, and we used that instrument there.
So at the SETI Institute, what's the day-to-day like? I'd imagine there's a lot of shuffling through data.
Well, no, there actually isn't so much of that. To begin with, the SETI group, the group that's actually using the Allen telescope array to look for signals that would betray the presence of somebody out there, that group is very, very small. And so almost everything is automated. I mean, it's just a matter of money. There's no money. So as a consequence, yes, every night we run the antennas for about 12 hours, looking at, in the case of what we're doing these days, mostly red dwarf star systems. And the data are pretty much automated in terms of the reduction. In other words, the instrument collects the data, goes to the next star system, whatever. All that's automated. And if it finds signals, and it often finds signals, so essentially every time it points, then it does the automatic checks to see, well, okay, here's a signal at, 23.45, whatever, on the dial. And it makes these checks to see, well, is this likely to be ET, or is this clearly a terrestrial signal caused by our own intelligence? So a lot of it is automated. There isn't much of us sitting around and looking at the data by hand.
No, that's interesting. Now, I know with a lot of the equipment you have, I read an interesting article that there was a shortage, a GPU shortage, because Bitcoin is taking up so much of that. Is there any credence to that, and how much of a negative effect is that having?
Well, actually, that is a true story, but it wasn't because of our efforts, because we have one graphics processing unit, in fact, the kind of compute power that you would find in video games. But we don't use them in general. However, the Berkeley SETI group does. And so that story was about them and how they were trying to improve the capabilities of their system. They needed more of these GPUs. They cost a couple of $1,000s each, I believe. And they were having to bid against the people who were using them for, Bitcoin calculations. So it's a true story. It didn't apply to us.
Oh, wow. Well, speaking of calculations, let's talk about the search for extraterrestrial life directly. So how helpful is the Drake equation when it comes to making a reasonable guess at the number of advanced civilizations in the galaxy?
Well, the Drake equation, we have a great deal of sympathy for around here. We had a conference last week which was investigating new ways to approach SETI, and the Drake equation came out fairly frequently. It doesn't really help you to do the experiment because you don't know all the terms in the Drake equation. So there's no way you can use it to really predict how many societies are out there that are producing signals that are going through everybody's bodies as they listen to this podcast. So we don't know that. I mean, it doesn't have that practical import. But it is a great way to sort of state the problem of SETI, because if there are very few planets out there, for example, that are habitable, then maybe you're wasting your time. Whereas if there are a lot of them, then you're beginning to think, well, maybe we're not wasting our time. So it's useful as a way of organizing our thoughts about the whole problem. Frank Drake, who comes in here frequently, he was here 3 days last week, he would be the first to agree with that, I think.
Sure. Well, you've said that your bet is we'll find signs of life within the next 20 years. So can you elaborate on what you would anticipate those signs being?
Yeah, well, depending on whom you listen to. I mean, I bet everybody a cup of Starbucks that we would find intelligent life within the next 20 years. And the reason I made the bet was, A, coffee is not terribly expensive, although it seems to be getting more expensive. But it was mostly based on the rapid improvement in digital technology, which is to say computers. The speed of our search is very strongly dependent on how much compute power we have. So Moore's law, which tells you that compute power per dollar more or less doubles every 18 months, suggests that, okay, in the next 20 years, the experiments being done by SETI would be able to check out maybe 1 million star systems. Now, that's a lot more than we've done so far. So if we could check out 1 million star systems, and then I figured we have a good chance of finding something, and that's why I made this bet. But if you're just talking about finding life beyond Earth, and you don't care whether it's intelligent or not, then you can listen to the NASA chief scientist who about 2 years ago said that within 20 years we'll find life, and she meant, microbial life in the solar system, and she might be right too. Sure,
well, there's a lot of talk about that. Do you personally think that there's potentially some sort of life, whether that's on Mars, Enceladus, Europa, or anywhere within our direct solar system?
Well, it's certainly possible. There are 7 other bodies in our solar system besides the Earth, where you have some sort of liquid water or liquids of some sort. I mean, on the Saturnian moon, right, Titan, there are lakes on the surface, but they're not lakes of water because it would all be frozen more solid than granite. But they're lakes of, liquid natural gas, which has a very much lower freezing point. So, you could say, all right, I wouldn't want to live in a lake of liquid natural gas, methane and ethane. Not for me. But if you're a microbe, you might not find that so terrible, particularly if you're a Titan Titan microbe, you might not find it so terrible. So that's one place. But there are 3 moons of Jupiter. There's another moon of Saturn, Enceladus, Mars, of course, maybe even the atmosphere of Venus. These are all places where it's conceivable that you might have life, because if you dumped all of the biota of Earth onto any of these places, and a lot of them are underground, but if you dump that somehow into these underground oceans, and then came back a year later, you'd find that a lot of them still have life, right? So life can survive in many of these habitats. The question is, did it ever arise?
No, I've heard that about near the vents at the bottom of the ocean and different trenches, but Venus itself seems so hellish, it's hard to imagine anything surviving there.
Well, on the surface of Venus, I'm sure that's true. I mean, it's 800 degrees, 900 degrees. That's going to break apart any complex molecules that you might have for life, sure enough. But if you go up a couple of miles, right, then you get to a layer in the atmosphere where the temperatures are the same as in downtown Chicago in the spring, okay? So it could be that if you had some floating life forms, like, microbes that could float in the atmosphere, and after all, the atmosphere is 100 times thicker than on Earth, so things could float pretty easily, then, it wouldn't be so bad. You get a little bit of sunlight, and you got some moisture. I don't know, there's at least one suggestion that the microbes could live on the acetylene that's in the atmosphere. That would be their food.
Mm-hmm.
So, sounds like a flaming good idea to me.
No, be like Cloud City. So how can we reconcile the Fermi Paradox with the belief that we're not alone in the cosmos?
Well, the Fermi Paradox is, just a claim that we don't see any aliens nearby. We don't see any evidence of life in space nearby, right? And so the suggestion is that at least for advanced life, intelligent life, well, if they're advanced enough, they could colonize the galaxy, and there's been plenty of time for that to happen in the 13 billion years since the Big Bang. So where are they all? That was the question that Fermi reputedly posed to his dining companions. And, it is true that we don't see alien spacecraft cruising the local galaxy. We don't see any evidence of astroengineering. We don't see anybody, landing in their spacecraft and walking out and talking to us. We don't see any of that. It's as if we're the only players on the stage. But on the other hand, we probably couldn't see any of that. I mean, there could be things even in our own solar system that are artifacts of aliens that visited about 1 billion years ago or whatever. And, they long went away, but those artifacts could still be here, and we wouldn't see them from the ground. We don't have the capability of finding them. So the fact that we haven't seen any evidence, to me, does not prove that the aliens are not out there, only that we haven't found the evidence.
Mm. Well, there's some who think they're already here. I know you've appeared on Ancient Aliens, so what was that sort of experience like?
Well, I enjoyed it a great deal because they gave us some pretty good sandwiches. So all okay by me. The idea that the aliens came down and helped us build the pyramids or the Nazca lines or any of the other things that are broached in Ancient Aliens, I don't subscribe to that myself. That's, I don't think that there's any good evidence for that. But it's very popular with the public. Ancient Aliens is in its 11th season, and it would not be in its 11th season if people didn't find it interesting.
No, there must be something that brings them in. But at the same time, you've also been in on a lot of episodes of NASA's Unexplained Files, which that's a more, I guess, conventional show, and that's been pretty fantastic too.
Yeah, well, could be. I mean, the idea that there are things that are unexplained. There are plenty of things that are unexplained. What causes cancer, for example, still unexplained. It doesn't mean that it's unexplainable. It just means that it hasn't been explained yet.
No, definitely. So things. The WOW signal is obviously one of the more famous incidents that's happened in history. In your time at SETI, has there been anything similar to that, or something that there might be some chance of originating from an extraterrestrial source?
Well, sure. I mean, we get false alarms all the time. In fact, when we were using the telescope down in Puerto Rico, the Arecibo telescope, I counted something like 10 signals every minute. But, those are all ruled out by the software, actually, because they can all be ascribed to mostly telecommunications satellites, actually. But in 1997, and I described this in one of the books I've got out there, we got a signal that for most of the day looked like the real deal. It was very interesting. Turned out not to be the real deal, by the way. It turned out to be the SOHO, European Solar Research Satellite, and this was just the telemetry of the data coming back to Earth. But, it was very instructive to get that false alarm because it showed us what would really happen if we were to get a signal, because a lot of the public thinks, oh, if you guys got a signal, you wouldn't even tell us, right, that kind of thing, some sort of conspiracy belief. But in fact, what happened was that we had this signal. We weren't sure of it ourselves. We were spending a lot of effort trying to track it down. And I kept waiting for the White House to call. He didn't call. I kept waiting for Will Smith to show up in a white shirt and a black tie, which didn't happen. I kept waiting for the mayor of Mountain View to call. He didn't call. I kept waiting for my mom to call. She didn't call. Nobody seemed terribly interested. But finally, I was half asleep because this had gone on all night. And the phone finally did ring, and it was the New York Times, and they did call. So they would have run with the story, except by then we had tracked it down and we knew what it was. So the facts are that if we pick up the signal, the media will jump on it first, and they will, in fact, run with the story long before we've done enough tests to be sure that we know what we're claiming.
Mm-hmm. Sure. Well, just today you had an article published about possibly searching for alien satellites. But if they really had such a massive number of artificial satellites, wouldn't those be detectable in some way by now?
Well, the idea here, this is an article by a Spanish astronomer, actually, and what he said was, look, if these guys have enough artificial satellites, and when I say these guys, the Klingons or the Borg or whoever, if they have enough of betazoids, if they have enough of these things, and if it turns out that you're looking at their planetary system sort of edge on, then these things will be sort of like a ring around their planet. And and it'll block some of the light if that planet gets in front of their sun, if you get a little transit there, a little eclipse. That was the proposal. And that isn't going to happen very often, but what they were saying was that we observe these eclipses anyhow because we're looking for extrasolar planets. So this experiment comes kind of free with existing science or astronomical research. And, I think it's a kind of an interesting idea. It's a clever idea. But, yeah, would the aliens put up enough geosynchronous, well, actually geostationary satellites for us to detect it because of the additional light blockage? And the answer to that is, I kind of doubt it, but maybe you don't know what a society, a million years more advanced than we are would do, so you can't really rule it out.
Sure. There was that one example recently where they thought there was a possibility, although a slim one, that there could be an alien-constructed Dyson Sphere around a sun.
Well, Tabby Star, which was in the news 2 years ago and has been in the news ever since, really, tremendous dip in the brightness of that star was witnessed a couple of years ago, down 22%. No star that we know gets dimmer by 22%. Go out and look at the sun every day, and you'll see slight changes in brightness when there are big sunspot groups and stuff like that. But those are on the order of 0.01%, maybe 0.1% at the most. So 1 part in 1,000. But this was 22%. So the question was, well, what was causing this? And one suggestion that was made at the time was maybe it's an alien megastructure, part of a Dyson swarm or something like that. But since then, additional observations with big optical telescopes suggest rather strongly that it's just dust in that solar system that occasionally blocks the light.
No problem. Okay, so one of the most obvious problems is distance. Do you think we'll be stuck with much slower forms of propulsion requiring some sort of generation shifts to travel to more star systems, or is it feasible that some sort of speed faster than light could somehow be achieved?
Well, according to physics as we know it, there is no such thing as a faster than light ship. I mean, Star Trek aside, because to have something going faster than the speed of light violates causality, and that's something that physicists are going to want to defend. So I don't know that we're ever going to have a faster than light ship. There is the fact that if you can get the ship to go up to 90% the speed of light, then the people on board age a lot less quickly than the people you've left behind. So if you could come back to Earth, you would find, all your relatives are gone, everybody you knew is gone, and maybe Earth is now, millions of years in the future, but you're still young. So maybe that would be okay. The trip for you would not take so much time. So maybe you could go to the stars that way. But the problem is not a new propulsion scheme, really. That's engineering. The problem is with physics. Getting any rocket up to, 90% the speed of light is something that, A, takes an enormous amount of energy. And when I say enormous amount of energy, all the energy production of the United States for the next 300 years. It's a lot of energy. And the other thing is, if you're going that fast, then every atom or particle that you hit in space, and there's plenty of that stuff, is going to produce a shower of X-rays that are immediately going to kill everybody on board. So you got to solve that problem too. So it's not easy. It doesn't violate physics. Maybe you can do it. But this idea that you just call up Scotty in the engine room, tell him to put the pedal to the metal, that's not terribly realistic in the next foreseeable future. Put it that way.
No, that does seem like a problem. I know even going to Mars, they say that the biggest issue is getting the astronauts there and not having them dying of radiation. So.
Yep, and that's a 7-month trip. That's nothing.
No, that's true. Well, if there was one specific question you could get a definitive answer to about the universe, what would it be and why?
It's big, really big. I think that the only definitive thing, there are many things you can say about the universe. We have a fairly good idea of the stuff in it that, lights up, like stars and galaxies, and for that matter, gas between the stars. That's all stuff we know about. We also know that it makes a lot of planets. We know many, many facts about the universe, in fact, especially, compared to people 500 years ago. But we also know that the universe, the things we know about the universe in general, cosmology, if you will, really dwarfs what people knew even within my lifetime, right? We know a lot more about galaxies. 100 years ago, nobody was sure there were other galaxies beside the Milky Way. And now we know of 2 trillion galaxies, so there are a lot of them. We also know something about the future of all this stuff, and that's something that, our forefathers never would have known when, for example, although the last star dies, or for that matter, when the last black hole evaporates. We know these things, and that's rather remarkable.
No, it definitely is. You may have heard that sound warning, but we can go a little bit over that. It's just because I have a conference call going on here. So a couple more questions. Recently, obviously, Dr. Hawking passed away. Do you have any thoughts to share about him?
Well, in the next 60 seconds,
we can go a few minutes over that. It's because it's on a conference call. Yeah.
Yeah. Well, obviously, there's a big loss to see Stephen Hawking pass away. I didn't really know him. I met him a couple of times, but he was a very ingenious thinker, and people like Stephen Hawking don't come along very often. So that's really too bad. When people ask me, well, what is the most important thing that Stephen Hawking did from a science perspective, I think the answer to that is his work on showing that black holes evaporate. Black holes are not forever. And there's that. But the other thing is that, he had this book in the 1970s, A Brief History of Time, and while not everybody read it and not everybody understood it, at least a lot of people bought it and put it on their coffee table, showing that for them, at least, science was important.
Sure. No, I think a lot of people don't really give enough thought to science nowadays. And do you think that's why we've, lost direction since, say, the Apollo era, when we had all our resources focused on one goal as a nation and as a society, and nowadays there seems to be some sort of feeling of being lost in the wilderness?
Well, I don't know how lost we are. It is true that we're not, investing nearly as much in space as we did during the Apollo era. But remember, the Apollo era, going to the moon, was more about politics than it was about science. There were plenty of people who said that the amount of science that came out wasn't terribly great, and that might be a legitimate criticism. You get a lot more science out of something like the Hubble Space Telescope, and it was a lot cheaper. Even though it wasn't so cheap, it was a lot cheaper. So I don't know. I think that the younger generation today is interested in science. I think they really are. Maybe I'm just being fooled, or maybe it's just a selection effect that the people that I see are interested in science, because otherwise I wouldn't see them. Maybe that's true. But I do think that there's a fundamental interest amongst many young people in science. So, and science is very successful at explaining things, yes, but if you can explain how something works, if you can describe how electrons behave, for example, then you can do things like build a cell phone or a television or something like that. So that's something that science has over many other disciplines. It has a predictive capability, and that's terribly useful.
Mm-hmm. Well, I'm personally excited about the Webb telescope. That should produce a lot of useful science, I would think.
I think it will, yes, it will. It's an infrared telescope, and that means, when you look very far away, almost all objects, most objects anyhow, are shining in the infrared, not in the visible wavelengths that our eyes see, because, of course, the universe is expanding, so that light has been stretched out, Doppler shifted, so it's all infrared. And Webb will be able to see that stuff. So I do expect it to find some interesting things in space.
Sure. Well, moving forward, how do you see SETI's role in astronomy and the larger search for extraterrestrial life?
Well, I don't know. Nobody knows. Clearly, the equipment keeps getting better and faster. So that's one thing. You're looking for buried treasure on an island, and then suddenly they give you a much better shovel, and then they give you a skip loader, and then they give you who knows what, a steam shovel. I mean, that's all predictable. What you don't see are the things that are not so predictable. But one thing that came up last week a lot, and that is the idea of looking for artifacts in space. Instead of looking for signals, look for stuff that somebody has built or garbage that they've left behind or something like that. And that's an area where, frankly, very little work has been done, partly because it's hard, and secondly because you don't quite know in advance what to look for. But that's a new, a relatively new approach to SETI, which I expect to see more of in the future.
Mm-hmm. Well, there's been a few different supposed pillars on Mars or whatnot that people try and point to as past evidence, but it's kind of like they're, I guess, trying to invent something that might not really be there.
Well, give me an example.
There's the famous face on Mars, of course. There's people who think they're different objects that look like they could be pillars or some sort of ruins, that sort of thing.
Oh, yeah. This is pareidolia, really, mostly. This is,
mm-hmm.
A lot of people write me with photos of the clouds, and they can see all sorts of aliens in the clouds. Well, I don't think they're aliens in the clouds. It's like, the Virgin Mary in a grilled cheese sandwich. I mean, you can see it, but I don't really think it's the Virgin Mary. And these things like the face on Mars, actually, when you look at that with a high-resolution orbiter, as has been done, then you see it looks like a rock. Mm-hmm. And you can argue, oh, well, yeah, but it used to look like a face, and now it's been, weathered away. Well, isn't that kind of a funny explanation for something that you're claiming is important because it looks like a face, and now the fact that it doesn't look like a face you're saying is important? So, that kind of stuff, it doesn't make any sense to me. I think if anybody had been on the surface of Mars, you would not find these occasional things that look like something. You would find the ruins of cities or highways, or you'd find something, cab tops from their soft drinks. You'd find something, and we don't.
No, it definitely makes sense. Well, before we let you go, is there anything new you're working on that you can tell us about? Anything at all?
Well, we continue to look at special objects like TRAPPIST-1, Tabby Star, Oumuamua, that asteroid that passed through the solar system. We do that. But our major effort is to look at as many star systems as we can, hoping to find a signal and, finding the money to continue to be able to do that.
Well, I definitely hope that's successful soon.
Well, me too.
All right. Well, we had our fair share of technical problems, but thank you so much for joining us. It was a great conversation.
Thank you, AJ.
All right, take care. That was Dr. Seth Shostak. We had a few technical issues there, but thanks for hanging in with us. And, of course, in the archive version, you're not going to know about all of those because those will be fixed. Well, this is it for the Ajay Bruno Show. Thanks for tuning in to this episode. We'll be back soon with more great guests and more fantastic topics to discuss. So, hope you join us then, and so long for now.